Hey, I was talking to our next speaker, Alamir Mohsen, but before I tell you something about his presentation, I'm going to read something to you that really stunned me. Alamir Mohsen is an educated architect, okay, facade engineer and product designer. He studied architecture at 16. So I questioned him, did you really study at 16? He said, no, actually, I studied at 15. So I don't know, you know, I had other things in mind when I was 16 and completed his bachelor degrees at 21. And then he also got a master, which is great. And I was trying to understand what the presentation was about. And it is about this. I don't know if you see it, but it is a 3D printed aluminium node. And Alamir is going to talk to us. Come on stage. He's going to talk to us about the method, the node.
Yeah. You can hear me, right?
Yes,
Perfect.
we can.
Perfect.
And you're going to talk to us about the software that you use to do this.
Yes.
And we can show this to the audience. It is absolutely fantastic. It may disappear at the end of the presentation.
Yes, yes, a lot. It's going to appear a lot in the presentation.
Circulate it and
please.
Okay,
so you have a node right now in your hand. This is 3D printed directly from the printer, ready to use. I'm glad to be here. So I'm going to present the story of our 3D printed nodes and, let's say, a piece of software and the whole idea about who we are. So I will start with a short, I have a couple of videos, so I hope you like them. So I will start with a short video explaining who we are and what we're trying to achieve.
Mein Name ist Alamir Mohsen. Ich bin der Gründer von Lithium Designers. Wir ermöglichen die Massenproduktion von individuellen Konstruktionslösungen für den Bau von Freiform-Gebäudehüllen. Immobilien und andere Bauwesen sind bekannt für deren ineffiziente Planungsprozesse, dessen zeit- und kostenintensive Entwicklung und den Materialverlust von bis zu 70%. Und genau dieses Problem lösen wir. Wir haben eine innovative 3D-Druckdesign- und Planungslösung entwickelt, die den Immobilienentwickler einen vollautomatischen Planungsprozess ermöglicht, welcher zeit- und kosteneffizient ist, mit 30 bis 40% weniger Baukosten und über 85% weniger Materialabfall liefert. Wir verfügen über 10 Jahre Entwicklungserfahrung, 11 internationale Auszeichnungen und Patente in Europa und den USA. Wir sind die Ersten, die in Deutschland und weltweit erfolgreich 3D-gedruckte Elemente für die Bauindustrie zertifizieren. Als nächstes werden wir unsere Zertifizierung auf ganz Europa, den Nahen Osten und die USA ausweiten. Unsere Vision ist die Massenproduktion von individuellen Lösungen.
Okay, so I hope I give you a quick insight what we're doing. What we try is to solve the problem of planning free-form geometries for building envelopes. So we have a known problem in the world, and this is like how free-form envelopes is like we talk about ineffective planning processes, we talk about like enormous CO2 emissions, and the material waste. When we talk about CNC parts, we talk about over 70% of material waste. And what we try to do is to solve this problem. So what we try to do, or actually what we managed to achieve, is we offer a fully automated planning process to reduce possibility for mistakes. And we reach like square meter price, which is around 1,000 euro per square meter, and we have by the nodes less than 5% material waste. And the most important thing is like we managed to have 80% reduction in CO2 emissions. So how we managed to do this is we have a method, LS3 method. This is something I developed in my PhD, and we came up with 2 building stones. The first building stone is a piece of software and our 3D printed nodes, and both of them has been run by us. So our 3D printed node is simply, we try to make a live connection. you can match it to any kind of profile, you can match it to any kind of geometry, and all these problems that happen between geometries and so on, we eliminated these problems, we took it in our software, so the architect or the facade contractor that they plan the project does not need to face these problems. And we offer them at the end a Lego structure that you can just stick it together and you build up the whole thing. Our software is really simple to see, to describe, which is all what I need is a base surface. That base surface will be automatically transformed and broke down into buildable elements. So we have the glass elements, the sealant, the profiles, the nodes, and all elements will be ready to manufacture. So I'm talking about the end of the planning, so manufacturing data. So to simplify this and explain the whole idea is we have here, let's say, the structure of our main software functions. At the beginning, we start to decide what kind of glass we plan to use. Are we planning to use flat glass? Are we going to cold bend the glass? Or are we going to use hot bended glass? All these parameters, we can feed the software at the beginning of the planning with it. And we move from this to point B, and then we try to break down the elements into just profiles, glass panels, facade features, and all element needed. And then we have a gateway for the nodes to topology optimize them. And C and D here, you get the manufacturing information in forms of drawings, lists, everything needed to just transform this design into buildable parts. Here you can see a bit of like the main core of our software. So we have a C# software, which is we connect all needed elements together, and we have these coded building elements, which means we have actually intelligent parts in the digital level. So every element just contains a set of data, describes exactly where it's placed in the project, which kind of parts are connected to it, and every needed information, even the coordinates in 3D world. So you can achieve everything you need, and you can get actually even assembly drawing and all the manufacturing information to build up the project from it. We have as well a library of building systems, a library of design constraints, and this part here, it's like under development, and we consider it the future, because this is we try to integrate as well artificial intelligence to build up our database. So if we already calculated the solution, we will not need to recalculate that one. And when we go to this database that we already built up and go to a solution that already works. Our last case study project at the moment is with Kaufland. This is like a hypermarket brand in Germany. And I'm going to give a bit of like this short video to show as well how our software functioning based on that design. So our software name is L3M. And as you see, everything we need is just a base surface. Have a full automated generation process of the nodes. And then you move to the profile. Which is we talk about the perfect manufacturing data. You can export drawings, elements, you have every cut in the element. This nodes before optimization, you can just get out, go from the gateway, and then start to optimize the nodes as well, and you generate the topology optimized elements. This will be you took in real time to 5 minutes. So this is how the project should look like. The main idea as well, and the idea behind the name Identity, was to try to offer the Kaufland to use their project or like let's say branches to strengthen their identity. And then we just took their logo and imprinted on the facade element, and we transformed this, let's say, boring 2D facade into a 3-dimensional facade. And the interesting thing is, like, square meter price compared to the standard like flat element is almost 200 euro extra. So we're not talking even about double price, we're talking about less than 5% extra price. This is how it looked like. And we hope to finalize this project this year. This is a next possible element in Dubai. We talk about 30 meter high parametric facade for an elevator. So it's as well as CAD. We can use the same method to make indoor elements. This is our pilot project in Germany. It has been already done 1 year ago. You can see here how actually the whole profiles has been connected, how the connected nodes as well. This is one of the first versions, so you can see we have a lot of screws, so we try to plan it, over-dimension it, let's say. But first project, we better to be on a safe side. But it all worked actually perfect. The whole facade been built together within 8 hours. And this is how the project looked like after completion. Second project we had was Überseequartier Westfield. It's in Hamburg. We talk here about 5,000 square meter freeform facade. Glass roof, I'm sorry. And you see this column, we had 34 of them. When we got the project, we had only line model from the client. And we transformed the whole glass roof into manufacturing data. We talk about 20,000 different profiles. We talk about 9,000 nodes. And we had for the glass panels only, we talk about 8,353 glass panel. What happened with the glass panel here was really interesting because we programmed the whole thing. We had a discussion with the glass manufacturer on Friday. We just pressed the button, we went home, and on Monday we delivered 8,353 finished drawing, fully dimensioned, fully clarifying everything with manufacturing DXFs, with everything he needs. We even got a call back from the manufacturer, and he thought that we delivered something wrong. He just didn't understand how this can be submitted within a weekend. But it was perfect, everything done with no human interaction. So to give you a bit of an idea about the sustainability aspects that we can achieve with this kind of automation in building industry, if we just simply compare the standard, like today, what we built using 100-ton steel or aluminum, we can change it and offer it for less than 20 ton. So we talk about 80% reduction in material, that these materials must not be bought, must not be manufactured, must not be transported. And here, what we need actually to think about is the sustainability on the bigger scale. On the whole, we need to consider the whole chain of planning a building, not only about generating parts, it's about how to generate the parts and reach the final product, that we have a project which is already standing. So this whole process here, we save in each stage. And all these savings will add up at the end in how sustainable what our solution is and what we can offer to the building industry. Actually, what we try to focus on is the sustainability for mega-scale projects. We're not talking about small projects. The effect here is not really noticeable. But what we talk about is this big-size projects where actually we need tons and tons of material. We need huge manufacturing capacity. And then once we start to save in this process, in this kind of project, here where we actually have a positive impact for sustainability of construction. So a bit of marketing slides right now. We have a patent in Europe, in USA as well. The certification we had in our pilot project, certification like project-specified certification. We have a German certification as well ongoing and hope to be closed by the end of this year. And we were going to move and widen the certification to cover Middle East and USA. We had international cooperations with a couple of companies as well, where we try to make mock-ups and market our system. This is last video 4 of the presentation, which is just showing a concept, what we can achieve when with any cooperation partner or facade system provider. The node is extremely flexible to any geometry, to any number of profiles. This is a couple of awards we collected in our journey in the last 5 years. Thank you so much for your time, and if you have any questions, I'll be glad to reply.